So good afternoon, everyone. For the next session, uh, we have with us Kamlesh Warrier, sir, which will be on the topic of solution of sustainable structure. Sir is a civil engineer with a diploma in business management, with over 21 year of experience in the application of specialty chemicals in civil applications. Currently working as a lead carbon infra solution with Reliance Industry Limited, overseeing primarily the application of carbon composite in various sectors. Now I request sir to continue with this session. Sir, am I audible to you?
Yeah, very well audible.
Okay, sir. You can start your session, sir.
Okay. My voice is clear, right?
Yes, yes, sir. This is clear.
Okay. Good evening, all of you. Sorry, I got late to join 10 minutes back, so sorry to keep all of you waiting. So I'm Kamlesh Warrior from Reliance Industries, here to present on the composites which can be useful to keep our structure sustainable. Yeah. So we have been doing a lot of work on developing new assets, right? But there's still a lot of shortage of assets in India. So while we are building new assets, if we are able to retain the old structures, or if we can make the old structures suitable for the current loading conditions and guidelines, then that can save a lot of efforts on building new assets in areas where we already have some aging assets. So that's the whole idea of presenting the solutions to you today. So since you will all be stepping out into the corporate world in a couple of years time, so thought of just introducing. Uh, just a minute. Yeah. My slides are visible, right, to all of you?
Yes, sir. Your slides are visible.
Okay. So this is just to give an example. This is an acid affected structure, an industrial plant where a metal refinery where a lot of acid processing takes place. And when we removed one of the columns which was covered with a protective coating, when we removed that, what we saw was that the concrete was crumbling, and there was a reduction in the reinforcement as well, because we all know that acid leads to corrosion of the reinforcement, and even the concrete started crumbling. So what we did was that we retrofitted this particular column, and what you see here is the entire column retrofitted with a carbon composite. How it works, I'll try to explain in the subsequent slides, but this is what we can do. So instead of demolishing the entire plant and building up new one, we were able to retrofit this particular structure. Similarly, when you talk about even the metal pipelines which are used for cross country transportation of oil, chemicals and all, even petroleum products, what you see is over a period of time it leads to corrosion and loss in thickness, which causes a reduction in withstanding the pressure. A similar pipeline retrofitted during the process, so we did not have to stop the process line, and even during the process or the manufacturing cycle, we were able to retrofit such a similar metal pipeline with carbon composite. Again, as I mentioned, I'll explain how it happens. Similarly, a bridge pier, you see the extent of corrosion in the structure, and we were able to retrofit it using a composite. So what we are talking about or emphasizing is on how can we retain the aging assets and how can we make it suitable for the current loading conditions. That is where a carbon composite and the product line from Reliance by name of RELINFORCE can be put to use. What is RELINFORCE? So they are a range of carbon composite. Uh, the reinforcing matrix is made out of carbon fiber, which are high strength matrix. So carbon fiber, you would all know, is almost 10 times stronger than steel, Fe500. So the carbon fiber what we use has a tensile property of 5000 MPa and a modulus of 250 GPa, so pretty high in strength. We have it in three forms. One is in the fabric form. We also have pultrusion sections, what we call carbon strips or laminates. and we also have it in a form of grid. So wherever you have huge surface areas to be repaired, instead of going for a wire mesh or a chicken mesh reinforcement, we can look at a non-corrosive carbon grid reinforcement for strengthening. So a bridge deck which has a huge area to be retrofitted, that can be this carbon grid can be encapsulated into a cementitious matrix. How it looks like. So when you look at a micro level, it is very, very similar to our reinforced concrete, RCC, where primarily steel is for tensile strength and concrete for compression. Same way in this particular matrix as well. The carbon fiber, what you see in a high tensile material, is encapsulated into a reinforcing matrix or a binding matrix, which generally is an epoxy. But depending upon the exposure conditions, this binding matrix can also be different of different resins. It can be phenolic, it can be vinyl esters. Wherever we have highly chemical resistant or chemical exposure conditions, we look at chemical resistant resin matrix as well. But this is how it looks like at a micro level, and forms a very high strength matrix to give us a retrofitting or a strengthening matrix. What is its benefit? We have been able to achieve strength up to almost now. This figure has further increased. Now we have a matrix which can give tensile strength up to the binding matrix or the composite matrix up to 3000 MPa tensile. So still 6 times stronger than steel. At the same time, the weight of these matrix is 1/5 of steel. So wherever thus the superstructure has deteriorated and we want to retrofit them, we can do it by without increasing the dead weight of our structure. So that is how it helps. So it is highly light in weight, very easy to handle. We have thermal compatibility up to 150 degrees. So in industrial applications, sometimes this becomes an impediment because there are areas where the temperature is higher than this. But in all other infrastructure structures, we don't face this issue. It has an excellent fatigue, very quick to install with very less manpower. So it helps in installing and bringing the structure back to life very fast. They are non-corrosive reinforcing matrix. So over a period of 20 years, when you see the life cycle cost, this proves to be economical. It doesn't ask for any further maintenance. And it comes in various options. So designer gets a flexibility to work with different profiles depending upon what type of deficiency he is trying to address. Yeah. What are the conventional ways of retrofitting? These are all ways. We have jacketing, we have steel pinning taking place, we have external columns being given to retrofit the structures, which are very cumbersome and time consuming, and also causes problem to the operational efficiency of the structure. If you compare it, they are very bulky in nature, increases the dead weight. So wherever you don't have a scope for strengthening the foundation and you just have to retrofit the superstructure, and you are not very sure about how good your foundation is, there it's not possible to increase the dead weight of your superstructure by way of strengthening. So that is where it becomes a problem. Requires a lot of artful detailing in terms of where the shear connectors has to be given, how many reinforcement has to be given. So it requires a lot of skill, and it is pretty time consuming. And it doesn't stop any further, because ultimately it is again the normal steel and cement which you are using for retrofitting. It doesn't stop any further deterioration, the root cause for which the structure underwent a reduction in strength. Vis-a-vis that, when you talk about a CFRP, it is pretty clean, very neat to apply, light in weight, easy to apply, very fast in application. And carbon fiber is non-corrosive in nature, so it doesn't cause any further corrosion. So it makes your structure maintenance free. What is the design philosophy? So when we talk about concrete structures, globally ACI 440 is the code which is being followed to retrofit concrete using CFRP. So what we do is that we try to get the details of the original structure, and depending upon what's the deficiency of that structure, we look at various types of strengthening, right from flexural shear, axial loading enhancement, even seismic retrofitting. You might have heard about what happened in Turkey, right? So, and we have a lot of structures which were built before 2001, when our seismic codes also got revised. So even seismic retrofitting can be done with CFRP. We can also enhance. So we come across areas where the structure has gone for, it was designed for a different use, but due to certain conditions, it is now expected to take a very, very different loading conditions. So which requires enhancing the capacity, even that can be done. And wherever we have old structures which has undergone deterioration because by virtue of corrosion, that can be rehabilitated. So we have done even 150-meter tall chimneys. So we have a design team which works on the calculation and gets the calculation for the customers. So all the retrofitting schemes which we provide to the clients, it also carries all the calculation sheets. So it is pretty simple for them to understand. And also the client's design team can verify the calculations what we have done. Similarly, we also did I mean, since everyone knows about the Lalbagh Ganpati, so there's a long bridge there. So we also did the retrofitting of that Lalbagh bridge in Mumbai, where the box girders were retrofitted using the CFRP. So these are the calculation sheets which was accompanied. Now we also do the beam retrofitting. You also have like pipe rack columns in a typical industrial structure where you have a lot of columns which supports the pipe racks or the which goes all along the plant. We had also retrofitted such type of structures. So what you see here is there the axial loading capacity of the column was increased by virtue of confinement process. So this is how the confinement happens for a column. This is generally done when you want to increase the axial loading capacity of a column. We also do the seismic retrofitting and the axial loading. So this is how what you see, a combination of seismic retrofitting and enhancing the loading capacity of your column. This is the actual on-site photograph of the Lalbagh Bridge. So what you see here is people working inside the box girder. So at the all along the length, we had the laminates been introduced, and also at the junctions we had fabric been installed. This is a jetty approach bridge where, because of the alternate wetting drying and also because of the humid conditions, there was corrosion in the piers of the bridge. We did the confinement of this particular pier with a CFRP. So this is how it looks. It doesn't increase the section of your pier or the structure, and at the same time it makes it very neat and clean. Becomes very quick to install, and the matrix which was used, or the binding or the epoxy material which was used, was moisture insensitive. So it also doesn't get affected by the moisture conditions. Similarly, a bridge structure which was this was done by our technology partners Dow EXA, from whom we got this technology in India. So we have also tried to show a couple of overseas schemes. This is again a bridge in Moscow, where what you see is at the flexural portion, the laminates were introduced. These are strips which are introduced all along the length of the bridge to support it in the flexural efficiency. Again, what you see here is the shear reinforcement which is done at the junctions of the I section girder. So different types of strengthening scheme, depending upon what is the deficiency for the structure, can be taken up using the CFRP. Now this was one bridge which was decided to be completely demolished to construct a new one, but then they were able to retain this particular entire bridge by retrofitting it with a CFRP. So as young engineers, when you move out in the market and when you start your journey, when you come across such problems, you can look at various advanced solutions to retain the structure, yeah, and which will also in turn help in retaining our resources. And probably those resources can be used for building assets in areas where we don't have such structures. Now, I also showed you the metal pipelines, right? So even in industrial structures, you'll come across a lot of metal structures which undergoes corrosion because of the ambient conditions there. Now, in a metal, as in concrete, we go with ACI 440. Same way in metal structures, the design codal provisions what is adopted is the ASME PCC2. And for pipelines, we look at withstanding the pressure which the pipeline has to take. So we talk about a standalone pressure design where there is a complete hole in a metal structure. So CFRP composite is expected to withstand the entire pressure. So there we look at a standalone pressure design. We look also at a deflection control design for long pipelines where the supports are at longer distance, and we need to look at the deflection control. Even the shear strength, I'll just show you a couple of photographs. So here also, like what we show, we support the customers with a calculation sheet. So it pretty well substantiates the basis on which the retrofitting scheme is designed. So this is a 40-inch PP flare line done within our own Jamnagar refinery, where due to pitting corrosion, there was a reduction in strength at various places. And this is purely a cold work. So what happens in an industry is that the client is not ready to stop its process because it leads to loss in revenue. So they look at options which are cold work and which doesn't require to stop their process line. And this is one technology or system which can be worked upon or which can be done even when the pipeline is in process or in manufacturing. So there's a completely cold process work which doesn't hamper the process or the manufacturing. This is how it looks. So a 150-meter long length completely retrofitted with CFRP and then finally coated with a UV stable top coat. Again, this is a cross-country pipeline for one of our biggest PSUs in India. So it's not that we have done it only for our own in-house requirements, but this is also done for IOCL. So this is the pipeline which carries petroleum product right from east to west. So this was done for one of their junctions in Orissa. So even for the cross-country pipelines, this can be used, which makes it very, very easy. So now here, with 2 or 3 people, you can look at retrofitting the pipeline at areas where there is a thickness loss. So in pipelines, there is a process called pigging process where a machine runs right inside the pipeline all along the length, and it identifies places where there is a loss in thickness, precisely the points where there is a thickness loss. So what the client does is that they dig out the pipeline at that particular portion, expose it, and that particular area is retrofitted with CFRP. So becomes very handy for such non-accessible structures. And once you do this, they are rest assured about its life. Similarly, industrial assets, as I showed you, the overseas infrastructure, the jobs which our technology partners did. Same way, this is something in a power plant where what you see is a header line which had a lot of corrosion patches. And if you want to stop the process line, it causes a lot of losses, operational losses. Even during the operation, it was retrofitted with CFRP. This was purely with a fabric. Similarly, even steel process lines can be retrofitted with laminates or fabric. Again, an offshore platform where what you see is what you see is the portion which is retrofitted with CFRP. So instead of completely replacing this by processing or by stopping the process, while it is in process, we get it retrofitted. And here in some portions, we just look at augmenting the thickness, whatever loss has taken place. And in some cases, we also look at standalone pressure design. So here what you see is there is a complete hole because of corrosion. So here obviously we'll have to stop the process line and we completely retrofit it. Here the matrix is expected to withstand the entire pressure which builds up in the process line. So as I was mentioning, it works on 2 principles. One is a standalone pressure design, and second is where you have support from the existing metal substrate. So there is a thickness loss and we want to augment that thickness with CFRP. So PCC2 outlines how for these 2 approaches, the thickness has to be determined of a CFRP. So that's how we do it. Coming to now, if similarly a hole which has happened in this type of a process line, again that can be retrofitted in a completely non-destructive way. Similarly, in petrochemical plants, you will come across tank roofs where they store petrochemical materials, and these petrochemical materials, certain of them are very corrosive in nature. And what happens is it leads to corrosion of the metal roof. Now, to change the entire metal roof is going to be a big headache and a long drawn process. Instead of that, this entire metal roof was retrofitted with CFRP. So the high strength property of the CFRP comes to a very good use in such applications. What other applications? What we do is we also look at acid resistance applications, because composites has a very strong background on material chemistries. So we also look at retrofitting the areas which are exposed to very corrosive chemical exposures, and we get this retrofitted using the high-end chemistries what we have. Like we have a chemical sump area, so this can be retrofitted. Now in industrial plants you'll come across a lot of effluent plants made out of concrete, and since they have a lot of acidic exposure conditions, they come across or they come for repair every now and then. So we look at retrofitting those structures with chemical resistant coating systems. So just to conclude on what benefit RELINFORCE brings to the table is, one is additional strength. We also look at corrosion protection. We increase the ductility of the structure. So areas where you want to make the structure more ductile, we can do it using the CFRP. Very versatile. So you have come across various photographs where different type of structures were able to was retrofitted using CFRP. And being light in weight, it is very easy to apply, and with minimal manpower, non-accessible areas can also be retrofitted. And it reduces the life cycle cost, because as I mentioned again, CFRP is non-corrosive, and if you use the right binding matrix, it enhances the life of your structure, because then that matrix is able to withstand the exposure conditions for which it is designed. So then it enhances the life of your structure and avoids any future maintenance. Just to give a glimpse of why RELINFORCE or why this product from Reliance. So the entire design, right from designing the system to the materials what we use for this, is made within the Reliance premises. And we also support our clients with installers. So there are properly trained installers who are able to install this material in right quality and gives the right deliverables for the customers. That is where we give an end-to-end offering to the clients. We have our own in-house resin manufacturing, and even the carbon and the glass fabric what we make is made in-house by Reliance. To give this tailor-made solutions for our customers, we have an application development center within our premises where there is a team of scientists who works on different resin chemistries. So apart from infrastructure where the exposure conditions are not very severe, but when you come to industrial applications, you come across a lot of varied and severe exposure conditions. And a standard product line generally doesn't work. And that is where this application development center provides a tailor-made solution for the customer. So this is the development center what we have within our composite manufacturing plant in Baroda, where the team of scientists works on developing different types of resins for different conditions. Since this application goes for developing a structural matrix, they also go through a lot of analytical testing, where even not only the carbon fiber and the resin standalone, but the composite as a matrix is also tested for various mechanical and chemical properties. So this is what is done in this facility. And based on that, we have been able to now successfully develop lot of products which till recent past were imported in India. So we have resins, we have underwater resins which gets cured even in underwater. So we have been doing a lot of underwater applications. We have also been doing high temperature applications where uh, generally resins which are not able to resist beyond 90 degree. We have been able to do applications which goes even up to 200 to 50 degrees. So we have been doing this with the help of, or we have been able to provide such solutions only because of the application development center what we have. Second is the in-house design team. So we have a material engineering center based out of Mumbai, where there is a full-fledged design team who works on composite designs. So it's not only that we look at infrastructure or the CFRP, but we also look at various other applications using composites. So this MEC works on using the materials which are developed by ADC. Using those properties, they do the design of various solutions what RELINFORCE offers. So MEC works on bridging the gap between the material science and the final applications. So as I was saying, it is not only the infrastructure retrofitting what we do, but we also make windmill blades. We manufacture metro bodies out of composites. We also make cooling tower profiles out of composites. So nowadays, all the power plants, whatever induced draft cooling towers, what you see are all made out of composites. And we have a major share in that market. And that is all was possible because of MEC. They were able to design this using the composites. So that is what we do. So just to talk about what MEC does for this particular application, we do the structural design and development. They look at the load path investigation for design. They make industrial design and new concepts, and which ultimately helps us in retrofitting the metal and the concrete pipes. We also look at strengthening RCC columns and piles, even steel beams and structures, and pre-stressed concrete structures. So this is what all we do with the help of MEC and the ADC. This is what a Reliance Composite division is all about, from where this product line is offered or comes out in the market. We have almost like 7 operating divisions: a technical fabric where this carbon fiber is converted into a fabric. We have a resin plant where we manufacture these different types of resins. And the carbon pultrusion strips, what you saw, this is all made out using a pultrusion process where the fiber goes through a heating process and it is converted into a strip. So, and then we have a fabrication yard where we also make tailor-made solutions for our industrial applications. Through filament winding, we make underground fuel storage tanks out of composites. So nowadays, all the petrol pumps, what you see, they have all the fuel storage tanks underground. Earlier days, it were all made out of metal. Nowadays, it is all made out of composites. We also have a mass transport division where today we make metro coaches for 3 metro companies in India: Mumbai Metro, Pune Metro, and Agra Kanpur. All these 3 metro companies today get their metro coaches made in our plant, and we are today making 62.5 meter blades out of this particular wind blade division in RCS. So this is all what we offer. So one of the offerings which I discussed today was for the civil applications. So each of this division offers solutions for different varied industries. So that is what I was mentioning. And this is probably only one organization where all these composite processing facilities are under one roof. So we have a complete back-to-back, I would say, know-how and the processing facility within one roof to give solutions which are pretty tailor-made. Thank you. I hope the information was pretty useful. So it's an integrated facility. As I mentioned, we have an end-to-end capability, right from design to material to parts. And we look at offering application and solution-based offering to the customers. Hope it was pretty useful. Thank you so much. Professor Aziz, all over to you. Any questions from the audience? Hello.
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 Hello. Am I audible, sir?
Yeah. You're pretty much.
Uh,
I
Sir,
am done
thank
with
you.
it. Any
Yeah,
any
yeah, sure, sir.
any questions?
So we will be sharing a link with the participants regarding the feedback. Over there, they can
Okay.
ask question, and if there is any question related to your session, we will mail you. And whenever
Okay.
you are free, you can entertain them.
Okay. Okay.
Okay, so thank you, sir, for your informative session and giving us your valuable time.
Thank you. Thank you for giving me this opportunity to present. Thank you.
Sure, sir. Our honor, sir. Thank you, sir.
Okay.